So, welcome all. Welcome to term one. You'll ever start in the quantitative method webinar series. Basically, like Dr. Mundazi Apidi, who has a background in physics and mathematics and the real world, corporate business, and other interesting places. And he'll talk today about responsible AI, how to tackle bias and other challenges in machine learning. That is both applied and certainly will talk with a lot of insight from this part of the working with the metaverse nowadays. So we have about an hour and 10 minutes. So we have come up to 2 o'clock. I think you're prepared for about 40 minutes, but you can also ask questions on the way. People who are online, you can post chats, messages to me. I'll sit on a separate computer and follow those. And I will also read those aloud to you. So you don't need to worry about messages that show up on your screen. And I don't have a remote for you, so I can just use the keypad to go on. And the sound go right there online. I think it should be okay. And what we get to that, I'll go questions if you want to have longer questions also that you want to discuss. So over to you, Muntasi. It's pleasure. The floor is yours. Thank you a lot for the introduction and for inviting me. Thank you for also inviting me for this to give this talk. I'm very excited. When the kind of love scientific talks and interacting with people in the university. So today, all right, actually, I don't. So today, I mean, if I could say, I usually enjoy giving talks when I'm standing, but I think it's so I'm going to talk about responsible AI, I think biases, some other challenges in machine learning. This talk is going to be a wholesome talk. I'm not going deeper into the machine learning models and elsewhere it comes, but feel free to interrupt me if you want, and feel free to have a chat after the talk if you want to discuss anything more into the details. So what my plan is the introduction, and then I'll talk about, I'll show you, discuss a case study of biases in generative AI. And this case study is based on the research study done by the Bloomberg. I will discuss about the responsible AI and ethics. And then at the end, I will go slightly more technically deep into the AI project lifecycle, non-representative biases, bias variance trade-offs, bias in the framework of statistical decision theory. Not much in detail, but just to give you an idea of how to understand things in the more quantitative and mathematical perspectives. So my background is I have a PhD in computational cosmology from the Stephen Hawking Center at the University of Cambridge, and I studied in galaxy bias problem. So my PhD was focused on understanding how to understand the galaxy bias. What the galaxy bias is when so in the universe there is a distribution of dark matter, but we can't look at the distribution of dark matter because it's dark. And the only way we can create the distribution of dark matter is by looking at the galaxy. But the galaxy space, the distribution is a very biased way because distribution of dark matter is distributed uniformly, and galaxies are only generated in specific regions in that space. So if you look at the galaxy distribution and try to infer the distribution of dark matter, it's a bias. And how to understand the distribution, how to understand this model, because there was a time when people were using a linear bias model in the data analysis, and the results they were getting were very biased and skewed. And so how to understand that biases, how to come up with a more robust and more generic relationship at higher order. So I studied that. I use a framework called the free aptitude theory, the framework which is based on the perturbation theory. And then we identified some high-order biases in simulations, which now people have been using in data analysis from different galaxy surveys in the world. And then after my PhD, I went to Geneva to do a postdoc. I worked on some projects funded by the European Research Council on developing model independent tests to get ancient theory or gravity theory or modified theories of gravity using the galaxy simulator. The data these experiments will provide us in future. And then I also started moving more towards machine learning models. So so understanding and developing models of machine learning to do the data analysis in cosmology. So I worked with the Black Island Institute in New York, and we developed some simulation-based deep learning method. And recently I moved to corporate, like I've been working at LNG, the financial service fund, as a consultant of AI and data science. Okay, so these are some of the publications in the past. So I worked on this GBK Python, this was my PhD project. And then the recent one, I developed a integration pattern cosmology based on network. And the idea of this recent distribution which is that now people are developing simulations, but simulations are not the most robust simulation, not the most accurate simulation. So we try to include all the data that we can, but still we can miss something. And if we use those simulations to do the data analysis to infer some of the parameters on simulation, then the results can be biased. So how can we tackle those biases, and how can we tackle out of the sample data set to infer some parameters from the data? So this was mainly about that. I also worked on the likelihood pre-inference method, because when you do the data analysis, we have to assume a likelihood function, and likelihood function depends on the model. And if you don't know exactly what model to use, because what model is preferable for the data, then there are methods people have been working on to analyze the data without actually assuming any specific likelihood function. So these are some papers in the past, but I'm not going to discuss anything about this. This talk is mostly about understanding biases, and I also try my best to relate this to some of the interests that maybe you guys will have. So to start with, what is the AI? AI has been very popular these days, and artificial intelligence is just technique which enables machines to mimic human behavior. It's a very broader field, and it's again an open debate whether we have achieved an artificial intelligence or not, or maybe we will achieve it in the future or not. It's still a very open debate. But still, this is what we understand. So the goal is to achieve the human intelligence at some point through machines. Machine learning is a subset of artificial intelligence, and these are some algorithms which basically like deep learning algorithms or maybe regression models or anything. But machine learning are the algorithms which understands the patterns in the data. And deep learning is a subset of the machine learning, and deep learning is based on a neural network. So neural network are the algorithms which have layers and the neurons within the layers, right? And nowadays, generative AI, people are talking about generative AI. Generative AI is a subset of deep learning algorithms, right? And now they're becoming very popular because generative AI has revolutionized the AI field, and there's a new technology in the AI space developed a few years ago called the transformers, and after the transformer technology, the new era of AI open, and this is what the generative AI is. This all about. So from 2010 to 2020, the most important application in the AI space was like more related to the supervised learning. The goal was that we are getting more and more data. We need to improve the performance using algorithms. So small AI models perform really well if you increase the amount of data, but at some point this performance will get better. Right. So the more effort and the research went into increasing the performance if you increase the amount of the data. And so people started developing more advanced algorithms that large AI models. And we saw the increase in the performance, but again, at some point, the performance valued, right? At the amount of the data is increasing. And now, this is the time when we are getting a lot and lots of data, especially the big companies and institutions. They have so much of the data, and then they want to analyze the data and extract some kind of a pattern which using some sophisticated models. This era is actually more about the generative AI. So last era was mostly about improving the model performance using complicated algorithm, but this here is most about the generative AI technology. So what is generative AI? It's a substitute of traditional deep learning and the multi-mimic or approximate human abilities by creating content. The content could be the text content or the video content, audio content, any kind of the content. And the idea, why are they called generative models? Because they learn the ability to generate new content from the distribution of the data. So any of the data distribution to provide. So any kind of the data they provide, it learns the underlying distribution, and from that distribution, it's able to generate the content, it's able to create the samples to content which from the distribution. So the large language model, just one small specific example of the generative AI models, and they focus more on the text generation. They create the content of the text. And then we have now the large vision models, large different type of the models. And these models are basically depends on the models called the foundation models. The foundation models are again like a very massive thing about them as massive machine learning models which can take any kind of the data. So it can take structured, unstructured data, all sort of the data. They can do supervised, unsupervised, reinforcement kind of learning, all sort of learning. And they consist of a lot of parameters and think of parameters as side of the memories, right? And these foundation models have almost billions of parameters. And these memories, these parameters can learn some kind of patterns from the data. So as an example, ChatGPT Gemini 3, generating predefined transformer models, they were trained on 45 terabytes of the data, and they had 175 billion parameters. And now we have like more sophisticated models available. Right. So how do we interact with these models? We interact with these models using prompts, right? So prompt is a text passed in large language models. So you write anything. So you can convert your text to a text. You can convert your text to images. You can convert your text to audio. Convert that text to video. Anything. But the way you interact with these models and with these type of technologies is through using text. And you usually have the context with you, window, it traverses the memory available for a prompt, and the model processes the prompt and predicts the next word. Right. So these are the predictive models by at core. And the way you can also think of them as supervised learning because the sequences of the words predicts the next sequence. And one of the major breakthrough in these models compared to previous natural language processing models is that these models can actually learn the content or context of the text. Because in the past, natural language NLP models, they were not able to understand the content, they were only able to predict the next word based on the previous word, but now these models can able to understand the context of the text. So I want to show you some case study. I'm not going into details of these cases, but this is an important case study, and this is how AI sees the world. So everyone has been very like people have been excited about the AI technology. People want to adopt AI technologies, but what are the consequences of adopting these technologies? And this is one of the consequences of adopting these technologies. There are a lot of positive sides. There's also a lot of negative sides. But as an academic, as an intellectual, one of the and things in a way that is more transparent and safe for the society. So these are what I will show you. It's not all. It's a case study done by the Bloomberg, and they use an AI image generator called Stable Diffusion. The Stable Diffusion is an open source model from Stability AI, is a new startup in the United States. There are other models as well, like DALL-E 3 from OpenAI. But OpenAI is not an open source project, so you don't know what data set they are using to train the model. But the Stable Diffusion, because it's open source, right? And this is how it sees the world. Okay, looks if you type the prompt twice. So the way it works is they generated 5,000 different prompts, right? Using 5,000 different images using different types of prompts, and they selected different images using corresponding to the same prompt. So if you write twice in Iraq, you will get something like this: a soldier with guts, right? If you write attractive people, what you get is images like this, which is young and light skinned. So light skinned young people are more attractive to AI. Muslim people, men with beards and hair coverings. A portrait photo of a person at social services. You see, majority non-white with darker skin people, according to a Census Bureau survey of income and program participating in 2020, 63% of people on food stamp recipients in the US were white and only 37 were non-white. However, AI sees most of them as non-white people on food stamp. A portrait photo of more protective of a protective person will. So it's basically a majority white dressing suit for corporate jobs. This is what AI thinks is a more protected person. A perfect house in the US is a very traditional concrete house, perfect house in China. No mention about the high-rise buildings in which the Shanghai practice is the typical house in China. I just took one image, but in the case of the resort and lots of images and very similar. House in India, brick using plays, 30 feet, something like that, but India is not like that, we all know, right? A photo of a person clean, right? A woman happily clean, right? In our two worlds, this is what AI thinks, right? Everyone pass. But so what AI is doing is actually amplifying the bias in generative by efforts to declassify the data. So how it works is so most of the AI image generators, the way they connect the data, they use the web to collect the data. And when they collect the data from the web, they also extract the caption and the text associated with that image, right? And so the way the AI model learns is that they predict a pixel based on the text, right? So it's a predictive modeling. And most of the text on the image contains a lot of historical biases against all these. So people post obscene images and that people post bias images. Most of the web content comes from the US because US has the largest registered website on the internet. And most of these companies, they may use the US or maybe the company's data providers from the US to these companies to generate, to build these AI models. So what AI is doing is basically amplifying the biases already present in our historical data. And these are the result of the biased training data, right? So this AI image generator use 5 billion images to train on, right? So 5 billion images, you can't produce these 5 billion images in a more biased, in a more unbiased way, or the internet to stretch these images, right? Stability AI, their founders have told the media that yes, they have invested a lot to remove significantly these biases. Yet after their effort, the latest model updates continue to perpetuate certain stereotypes in this, right? So there's a co-founder, it's a company LAION. Its co-founder, so LAION is the company which provides the data stability AI, and they have remarked that image generation as well as the software we have, that's the exact worldview. During the data provided by certain nonprofits, which they for some reasons that time and India. So what AI is showing you is the worldview of a very specific, very biased group region in the world, not everything. And similarly, OpenAI also acknowledges that the E model exhibits a bias towards Western perspective. So major concern is the rate of the transference because these models are becoming very sophisticated, very complicated. And for normal people, even people who are adopting these AI technology, it's very difficult for them to understand how they work. So they go transparency. Most of the companies they're relying on the open source project because they think using the open source project will introduce the transparency in their process, but still the model becomes so complicated for common people, it's very difficult to understand how they develop or they come up with some decisions. Right? So, but transparency is important, and then making sure that the AI system are transparent is one way to mitigate these files. Right. Also, we don't have time, but I have this link, you're the link, and And recently in the US, there was an ad running for anti-Biden political acting happening, and they used AI to generate these texts. And this video was very biased to the white soldiers at the border, and they were doing their best to stop illegal activities, right? Which is very biased because they use this AI to generate these images, but normal people thought that they were secretly the realist. And an expert focused forecast that up to 90% of the internet content will be inherently produced in coming years. Like if you don't do anything about how to mitigate and how to deal with these biases, things will become much worse in future. Okay, so this is the paper from people at Stability AI, and they provided some kind of framework to deal with these biases. Again, it's a massive problem, and people don't know how to solve it. They're trying their best to deal with this bias. But one of the AI research scientists, one of the co-authors of this paper, he said that we are projecting a single worldview of in the world instead of representing a diverse kind of culture and visual identities. And one of the suggestions from these companies co-founders was that maybe one way to deal with this bias is instead of using one data set to train these models, we can rely on the data set from different countries, and we can ask the government to provide the data set representing their culture and their values. So in this way, they can at least mitigate all these biases on the AI model. There's a case study again by Bloomberg on bias in generative AI. So what they did is they used again 5,000 plus images, and they wanted to understand so they used 40 different different job descriptions. 7 of them were high-paying jobs, 7 of them were low-paying jobs, and 3 critical activities, right? And they wanted to understand how AI sees in terms of the skin color and also in terms of the gender. So what they use is when they calculate these images, they calculate the average color of each pixel from different parts of the image, and they categorize and they use this scale from 1 to 6. So 1 from the very light and 6 to extreme dark. And this is the scale a lot of researchers and dermatologists also use in their studies. So this is what they call. So the analysis showed that for every high-paying job, images were dominated by lighter skin tone. The subject with darker skin tones were more commonly generated by terms like fast food worker and social worker. As you can see on the top, you have the high-paid job, mostly dominated by the white pixels or light pixels, and the low-paying jobs you can see on pictures the housekeeper, janitors, dishwashers, kitchen workers, mostly dominated by the dark pixels. Again, and then now this is the result for the gender. So we each image depicting a perceived woman, stable diffusion generated almost 3 times as many images of perceived men. Most occupations were dominated by men except for low-paying jobs like housekeeper. As you can see, the dark green represents men and light green represents the woman. So you can see and for the bottom mostly dominated by women, and the top mostly dominated by men. But if you look at so there is a data provided by the Bureau of Labor Statistics in the US, and they provide they provide the data on the average data on these job occupations and also the monthly pay. So on the x-axis you have the monthly pay or the annual pay, and on the y-axis you have different topics. And you can see that this dotted line represents the data of labor statistics. You can see that the images generated by the AI and the AI model is very biased. And this is for you go up with the lighter steering, go down with that big state and so anyway, so one of the example is if you look at the data, so data shows that 34% in the US are the woman represents 34% in so So if you look at the data provided by the Labor Department, women comprise 34% as judges. So there are 34% of the women are judges. But in the images that we get from the AI, only 3% of the women represent the judge. Right. Similarly, if you look at the women and people of color frequently depicted in low wage roles by AI, the 70% of fast food workers images had darker skin tone, despite 70% of actual workers being white from the data. So this is kind of the bias that these AI algorithms, AI tools are amplifying. And this is actually uh, I mean, it's dangerous because these tools are being used in different departments. Like people have been using started to use the criminal to detect criminal activities, also to do the visual communication, facial detection softwares, and if AI systems verify this, then some minorities and non-white communities can face some consequences. So this is from my experience, and I think when I was still in my current job, there was one task that I got reporting, and there was a startup called AI, and they pitched MNG to use this startup for the recruitment process. And so the same thing is to analyze from the AI perspective and the biases. What they do is they based on the 5 to 10 minutes of the video, they assess the candidate, and they give you an AI score, right? So in the recruitment, companies are already using the AI system. So for example, when you submit your resumes, they use AI system to give you a score, and then based on that score, based on the keywords and everything, and how AI sees their application, it will give you a score, and based on that score, either you will pass on to the next step or not, or you get a rejection. But in this way, they will assess you based on your video interview, right? And this is problematic because the data they are using is not the fully representative data, right? So there could be problems like, for example, if someone is ill or coughing, AI won't be able to detect. And AI won't be able to give the value of the content, right? So it's very difficult for AI to quantify the context in this case. So the only way AI can tell you your rating is based on maybe the sentence structure, or maybe the grammar, or maybe your accent, right? So if someone's accent is not understandable by AI, those candidates will not get high ratings, right? So this is a very problematic. I told them as well to make sure that they understand the bias in the data they are using, and also the consequences of these things. I, I was not actually used in 2018 such a system, and they found that the system, at some point they found that the system was very biased against women applications. And so they're abandoning that system, and now what they're using, they think it's a more unbiased system, and it will take the data for them is on the big revenue. So again, so all of these things are becoming very complicated. So the idea is you need to understand the responsible AI. What are the principles for the responsible AI? We don't have the harder fast rules, and we can have organizations that will be developing their own rules for responsible AI and ethics. The first thing we need to understand is the AI is not infallible, right? So the AI can identify biases in the data. And so we need to adopt, we need to adhere to the rules surrounding the transparency, accountability, privacy, and security. And we should have some framework to understand the outcomes of the AI model, right? So the explainability of the AI. So these are some generic responsible AI and ethics requirements that people should understand. People, AI should be socially responsible, so AI should avoid creating or reinforcing unfair bias. AI should be built and tested for safety. AI should be accountable to people, so we should have a framework for explainability if someone wants to understand the outcome of the AI. AI should incorporate privacy design principles, and AI should uphold high standards of scientific excellence. AI should be made available for those that have already researched. We get not very hardcore rules, but this is again all the organizations who are building the responsibility and ethics principle, they are using most of these principles. But we also need to understand that there is more to AI bias than bias in data set, right? So there is a whole concept of statistical interpretation bias, the whole concept of human bias and systematic bias. And this is why I want to focus the rest of my talk to understand how we understand the biases in the data and how we understand the biases in the models, right? So if you look at the AI, the product life cycle, this is how really it works, right? So if you want to analyze the data, you're working with a data-centric product. So first, you start with problem definition, right? So that you now define problem, identify the goals or your work for. Then you load the data into relevant packages, right? So on the computer, and then you do some exploratory data analysis. And when you do the exploratory data analysis, there you want to understand whether there are some biases in the data, there is some outlier, there is some missing items, or some things like that. Then you do the data preparation. You look at the features, you select the features to think relevant for your problem statement, you do the data transformation, then you evaluate your models, and when you evaluate your model, the machine learning, you stick your data into training and testing data. So the rule of thumb is 70% goes in training the model, 30% goes in testing the models. So 30% goes in cross-validation, so validation of your model, and 10% goes to the testing of your model. And cross-validation method is also one way of removing some biases within the organization. But biases take down, for example, if you starting with the problem definition, if your forward definition is biased because you don't understand something and you want to use your view, it can start from this statement. But the anchor source of the bias is the data, right? So or the speaker you are selecting. So if you're presenting the wrong picture to solve or work on this problem, you're completely biased. And then, of course, evaluating your models, when you do the gradient split, when you split your data set, again, the bias of non-representative data can come because if all your data contains different subgroups, then you need to understand that you're not randomly sampling your data into gradient test sets if you're using the certified company, which is what. Again, when you do the answer parameter query or you do the model identification, so identifying the right model is important. If you're looking at the dimensions of the data, and it's low dimension, large dimension, little more example, the data by models, right? So it's a third. So going back to the basics, the understanding the sampling. So how does it work? So for example, if the data set represents population, suppose you want to understand, if you want to look at the average height in the UK, the most straightforward way to go, if you look at the data from everyone in the UK, like maybe millions of people in the UK, so then you have millions of data points, then you calculate the average ticket, the mean in the standard deviation, the whole distribution. That's the population data set. But it's impossible. And why would you do that? Or why would you collect the means, the data just for the simple problem? So instead of doing that, what we do is we go and randomly select the samples. So if you are sending there 100 samples, 1,000 samples, 10,000 samples. And then you look at your level descriptor statistics, you understand the sample average, sample mean, and the standard deviation, right? And then you believe that your sample is the correct representation of the underlying population. And so the statistic you're doing will provide the unbiased result, right? So one way of the bias that can come into this problem is your sample is not a representative of your underlying population, then your result will be biased. The second way your result will be biased if you're using the bias estimators or bias statistics, right? So if you're using the bias functions, then your results will also be biased. So what is the bias? What is the estimator? So estimator, for example, is a function of the data. So if X is the data, that's your C of X is a function, and T is an estimator of that function. Right. So an estimator T is a function derived from the sample data X used to estimate a population parameter. The estimator T is a random variable, so it varies with different samples. The actual estimate for a given sample is a fixed number. An estimator is unbiased if its expected value is equals the parameter for all possible values. So what is it? We, for example, if you select a sample, apply your statistic, you get a number. You select a new sample, apply the same function, you get another sample, and you get a bunch of these samples, and the average of these samples is equal to is the same for all the theta for all the samples, then you say your estimated in the C unbiased C, right? So making sure that your estimated is unbiased is also very important. So what is the non-representation data? Let's suppose you have a population. So there's suppose you have a red, 70% red and 30% blue. And you randomly select the points from this people. And then you randomly selected your point, you selected 60% blue and 40% red. These data points are selected from this data set. When this one contains 60% blue, 40% red, and this original one contains 70% red and 30% blue. So this one is not the representative data, right? What can you do? What you should do is you should only randomly take red from the 70% and randomly take blue from this 30% and making sure that 30-70 ratio remains the same in this training data, right? If you do that, if your sample contains the 70-30 ratio, then you can say that your sample is a correct representation of your population. If not, then your results will be very false. So most of the time so there are two types of sampling. They should be a lot like that way. But one way is the random sampling. You're randomly selecting the samples from there to like the cheapest. Yeah. So what is the advantages of random selection? Simple and it's easy to implement. And it works well for large data sets where the sample can be represented in entire data set. Right? Then you can apply the random. So if your data set is small, then it can introduce some sampling bias. Right? And if your data set is dividing into subgroups, right? Specific subgroups, then doing the random sampling can introduce a broad representative bias. So the way it works, you should do the stratified sampling. The stratified sampling divide the data into subgroups and randomly select the samples from that subgroup, making sure that the ratio remains the same in your sample. So, for example, if you're doing a survey for 1,000 people, right, and you want to gather some insight from 1,000 people, and if you opt for a pure random sampling, they might end up with a skewed gender ratios, not reflective of the general population. So, for example, in the US, they have 51.3% of females and 48.7% of males. So, any samples you collect to do the survey, you need to make sure that the samples contain at least 73.51.3 females and 48.7 males. So if you're collecting 1,000 samples, you need to make sure that 513 are females and 487 out of 1,000 are males. Then your sample is the correct representation for the population. Right. So what are the consequences of the poor quality data? Basically, if your data set is not the representation, then you will get inaccurate predictions, and your bias will get amplified. Right. So what are the solutions to enhance data representation? So what is diverse data collection? So employ inclusive and varied data collection techniques. Data enrichment, you need to utilize bootstrapping or synthetic data generation to improve the data quality. Sometimes, so this is important when you have a small training set, like a small data set. Then you can either apply the bootstrapping method, or you can generate the synthetic data based on your own. Adaptability and robustness, implement domain adaptation and regularization to maintain model reliability, continuous monitoring, bias mitigation, deploy some tools to detect and address biases, ensuring fairness. Human in the loop is very important in any AI adoption or any kind of the data analysis project. You can't automate the whole end-to-end process. There should be human in the loop at every stage in this project life cycle, making sure that at every step there is no bias and everything is fair and transparent. So this will give you like a very, very broad overview of like the machine learning models. Machine learning models can be divided into three categories. You can call it the supervised learning algorithms, unsupervised reinforcement learning. So the supervised learning algorithms learn from the labeled data. So the model is trained using a data set where the current output is known. The goal is to make the predictions of unseen data. And therefore, this labeling is also important. So if you label anything currently your data in sample, then of course you are doing those predictions going to do bias. Unsupervised learning algorithms use learn from undelivered data and they categorize the data into different categories. And they are used to identify patterns and structures from the input data without any guidance. Reinforcement learning, they learn from interacting with this environment, right? The model learns to make prediction by performing certain actions, so there's a evolves the penalty, and this is called they learn. So some of the key concepts is, for example, if you're doing the regression task, if you want to understand the relationship between your variables and your predictors, then you can either use regression. Regression is an example of the supervised learning technique. Classification is an example of the supervised learning technique used to predict the category. So, for example, if you want to your output in a category of spam or not spam, this is an example of the classification algorithm. Cluster is an unsupervised learning algorithm and they used to categorize groups with similar instances based on features in the clusters. So how do you choose the right model, right? So I will not, again, take a lot of time, but I'm not going into details. But I just wanted to give you a framework of statistical decision theory, how it works. So the idea is like statistical decision theory is key in making the most informed prediction by averaging outcomes of similar past situations. Anything similar past situation, you calculate the estimation, and then based on the estimation, you predict. And in this theory, you need to have a loss function. So, for example, if you loss function is a method to evaluate the prediction accuracy. So, if you're building a regression technique, the loss function is the square of the differences, right? But you can use any loss function based on the problem. The goal is to select the model that minimizes the penalty imposed by the loss function, effectively solving an optimization problem. So, to expected prediction error based on the function or the model they use is equal to the expectation of the loss function. So this is the loss function there. You can really draw what the least square method, but you can replace this any loss function. If you solve this problem or this equation, what we get is the f, which minimizes this expected prediction error, is the expectation, the condition expectation value X here, like the expectation of y given X is word, where is the condition expectation, also known as the regression function, right? So in the linear regression case, least square method assume that f of X is a model is approximated by a globally linear function. K-nearest neighbor is an algorithm in machine learning which is used to identify subgroups based on some instances. And this algorithm assumes f of X is well approximated by a locally constant function because locally, when looking at a local point, it approximates, it calculates whether a new instance belongs to this group or not, right? So if you're using a categorical features, so categorical features or categorical variables can also use this framework. All you have to do is use a different loss function. So if you're using a categorical feature, the loss function can be represented by k multiplied by k matrix L, where L will be zero on the diagonal and non-negative otherwise. And a specific element as L to K behavior, one element at this column. This is the price paid for classifying an observation wrong to this wrongly predicted down. So we solve this the whole previous thing for the categorical variables. The solution is known as a base classifier, and the classifier works for variables by using the conditional distribution levels. The error rate is for the base rate. So base classifier in the classification algorithm is the baseline. Right? So you need to achieve that level of classification, and most of these algorithms like k-nearest neighbor, even the linear regression, try to approximate it to the baseline. Right. So any kind of decision, any model, there is a you can write the expected prediction error for any models. This bias is bias variance. This is what we call the bias variance in the composition, and this is so for any model you use. So for any model you're using, you can write the expected prediction error in terms of three components. So there is a concept of the bias square, the variance, and the irreducible. It's irreducible, and it's just an error you can't deal with. It's just the temporal bias. The noise is in the way. The variance is and the bias is what you can basically change. So you can based on your problem statement, whether you want your prediction to be precise or not precise, how much variance you want in your outcome, or whether you want to remove the bias or not non-bias. But there's always a trade-off between bias and the variance. So what I really advise is this is a useful for the bias versus if you have the bias, high bias, low bias, low variance, high variance. So for low bias and high variance, you can see everything is clustered together very precisely. For low bias and high variance, you can see the data points are varied, but they're not biased. Right? This is bias very low, but everything is surrounding this. For high bias and low variance, for low variance is very precise, but it's exactly biased. The results are biased, should be here. And for high bias and high variance, you can see the data from the standard. So what we want ideally is low variance, low bias, which is not possible. You need to compromise someone. So sometimes if you want to already generalize more, but you can actually accept some degree of the variance, you basically want high variance but low bias. But if you don't want to worry about the bias, but you want to worry about the variance, then basically you choose the model that provides high bias and low variance. So it depends on the problem that you're using. And this is the model complexity graph. So as you increase the model complexity, basically the model complexity means you're adding more and more features in your model, making our model more complex, then your variance will increase. So variance means the variance of the prediction will increase, and your bias will decrease, right? But if your bias will decrease and your variance will decrease, then you're losing the whole purpose of the predictive modeling, right? So if you're using less integrated model, then your bias is very high, but variance is low. Think of it then as like a regression model. So if you're in regression, you get like a low variance, but the model can be biased because not all the relationships are linear, for example. So you need something like in between, right? So we need like some kind of a model, an optimal model where you can have a certain bias, certain variance. Right? There's a saying from this scientist, John Newman, he's one of the fathers of modern computation progression back in the 1940s. He said, give me four variables, and I will fit an elephant. With the fifth variable, I can make this turn bigger. So this is what outcomes raise a risk, right? If you add on more and more variables, you can actually fit any data set, right? But you need to make sure that you're not overfitting your data. So this is what overfitting is underfitting is. So you're thinking of very, very simplistic model. If the data is related value, but you're really very simple model, you're underfitting your data. But if you have this model, if you overfit every point, you are pretty great in the training data, but for your test data, your prediction will be off, very large sample, with very high variance. So all you want is not the underfitting or overfitting, but the accuracy, right? And same goes with the classification problem. All the BOD of the parts of dimensionality, the part of dimensionality, if you increase the data points, if you see the more features in your modeling, then there is something called the term for dimensionality. So dimensionality can be things really burst. One of the example is the local versus global problem. So regression data is a global method, right? Use the entire data set to fit your model. But for example, K-nearest neighbors classification algorithm help you the local approximation of data points. So if you're taking the local approximation of the data points, then for higher dimension, it's actually very complicated because the whole idea of the local is really a higher dimension. So for example, if you're using the KNN model, and if you, for example, in 10 dimensions, if you're using 10 features, to capture 1% of the data for a KNN local approximation, you need to include 63% of each dimension range. Because in KN, what we do is you create a neighborhood, and within the neighborhood, all the point within the neighborhood you approximate them, right? You make it average. So if you define the neighborhood in a higher dimension, let's suppose a 10-dimensional hypercube, you have to define a small hypercube, and then in order to capture only 1% of the data, you need to include the 63%. So basically, your hypercube, small hypercube neighborhood, will have to include the 63% of the entire data set. Or 10%, to capture 10% of the data, you need to include the 80% of the entire data set. So the whole idea of the locality loses its meaning because now it's actually a global problem, right? Only in 10 dimensions. These are called graphs, which shows that for lower dimension it's okay, but as we go to the higher dimensions, then things go much worse, right? And this is because of the sparsity problem. Why? Um, because if you look at this one dimension, so in one dimension, the data is clustered like this. If you look at the two dimension, it's scattered like this. And in three dimension, this is becoming more and more sparkly. So the sampling density becomes very and if you want the same kind of the accuracy in your model, then you need to improve the training sample exponentially, right? So let's say if you have 100 data points in one direction, if you're using only one feature, one dimension, you have 100 data points. And if you want the same level of accuracy, you want to model in 10 dimensions. So dimension represents the relevant features. If you're doing 10 features, you're doing the for example, the reflection or whatever, you will need 100 to the power 10 data points to achieve the same level of density. So the density decreases very exponentially increase the dimension. So therefore, it's not always the right thing because sometimes you think the more data, the more features we build in our models, we get the better results. But we know probably what the parts of dimension is very important. Right. So feature selection is important and dimensionality reduction techniques like PCF and component analysis. So if you have 10 features, you need to understand which feature are the more relevant feature for your analysis. So try to make your feature a subset of the features from the whole set, right? Yeah, I think features are like predictors. Yes, features are the predictors. Sometimes you can create the feature and if you want the feature to generate this. So you have the data, you can create a new variable, a new feature entries. And choosing the right metric, performance metric is also important. So for example, if you have a data set with these two classes, A and B. So A has 90% of the data points and B has 10% of the data points. And suppose you build a machine learning classification model using the training data to predict a new instance in class A and B. If you always guess that the instance is not B, right? It's a very stupid classifier. You build a classifier, if it, any point event is not B, you will be correct 90% of the time, right? And if you tell this stupid model in front of people like my model is 90% accurate, and people will clap. Right? It's a very good model. It's a very stupid model because it's not B. Right? So in this case, accuracy is a very stupid performance metric. All you need is a different metric. But it is something on the inclusion metrics, where you use a different metric to evaluate your classification algorithm, right? So the precision, for example, the precision is the ratio of the true positive divided by the true positive plus false positive, right? And then when you use precision means sensitivity, right? So type 1 and type 2 errors. Sensitivity is the true positive, the natural true positive versus true positive plus false negative. And so if you want to increase your true positive rate, you will have to compile your false negative rate, right? So there's a trade-off between precision and sensitivity. And therefore we need to make sure that that you choose the right one. So I think I'm taking more time, so I'm not going into data distribution shift. But this is something I also wanted to register. But I think I'm taking more time, so I'll just skip this part, data distribution shift. And if anyone is interested, I really research about it in more detail. But the conclusion is that
First of all, the data rules are behind that schema. We should make sure that we understand this problem, because now institutions or organizations are adopting AI tools, and in our research and learning, you're also using ChatGPT and other tools. So we need to make sure that we understand that these are biased and they cannot produce hallucinations. And so we need to adopt these technologies in some responsibly, ensure that inheritance around transparency, data privacy, and safety. Then non-representative bias and setting metrics should be able to avoid non-representative biases if you're building any kind of analysis using the model. And bias due to the modeling is also very important, and make sure you understand how to choose the right model, how to be the right metric, how to be aware of the personal dimensionality and everything. And the complexity of the function, remember, complexity of the function grows with dimension, for the same accuracy as the dimension, you can read the side of the training data, it's so cheap. And so the AI is not a magic box. Garbage in, garbage out, right? So that we're providing here, same thing. So use the good quality data, whether it teaches that like this non-representative bias. Thank you.
Thank you so much, Muntazir. This very interesting introduction to AI and a little bit beyond also. Yeah, so questions, please. While you're, I think all the chat questions, you open there on your screen, you see the chat, because unfortunately I cannot see them there. But the question is, one question is here in the room. So over to you.
Yeah. You mentioned that previous language models couldn't really understand the context, and now AIs can. And I was wondering if the AI's ability to understand the context facilitates the AI's ability to predict what comes next. That's what I was wondering about. Whether it's understanding the meaning of the context allows the AI to generate more easily or effectively.
So understanding the meaning of the context more exactly, this is exactly what is happening in ChatGPT and other models, because they understand the context of your prompt.
Yeah,
they can more easily generate the outcome, and the outcome is more relevant to the prompt you're using, right? But this is possible. I mean, this is what they're doing.
Yeah.
So they're using what is called, they understand the context, and they also use the prediction based on the context as well as the words, the number of the words they have already predicted. Okay, so that every word they're predicting, the model is predicting it based on the context and as well as and the number of the words which are already being predicted by the model. Okay. So it's basically a supervised learning algorithm. But again, yeah, this is true.
Okay.
So that's why they're producing more context, not easily, because they understand the context. But then this is also important to understand, because they understand the context and they understand the text-based model, you need to understand the importance of the prompt.
Yeah.
So the prompt you're providing. So if you provide a garbage prompt, it will provide a garbage answer. If you provide a very specific prompt, it will provide a very specific answer.
Yeah. Over here, and then there's one meeting.
Can you go back to the slide with the classifications of the loan, the graph for optimal or for the unfinished?
This one?
No, the one that had over. Yeah. Yes. Okay, so we're thinking about classification and a lot of the technology that we're using, particularly in schools, for example, classifying student behavior as deviant, not right, they should get punished or whatever, or the chessboard is the actions they're using the student is below and it's student is not, or what have you. The optimal one still obviously misclassified. So our kids, essentially, if I'm thinking about kids that in the classroom or people in real life, those stars or the blue circles, are people that could then be sent it from school. So which obviously is just something about how we use technology, and also human ability is already something that. The question then becomes how can we hold the creative of these and people kind of working with them who may not be out in the world implementing them? How can we start to hold them accountable for doing some of what you're talking about? And or like, what is their responsibility to do so now with that, like, look when they're deploying or saying like, yeah, here is the model that we have, here's the technology we created. Obviously, no one going to be sitting there saying that they have like a 90% success rate because they have no garbage in. But even in the best case scenarios, then how do we make that happen in less? I have one related to it, and it's also we asked about, are you aware of any regulation around the AI, generative AI that's actually having insight from different corporations trying to
Yeah.
so just
To answer your question, like it's not possible to achieve 100% accuracy in machine learning model. There will always be some kind of the trade-off, right? And this bias, this graph which shows the trade-off between true positive and false negative. We call this. So if you are building the classification algorithm, we need to make sure that what we want to sacrifice, right? So you want the good people, the good students. So also sometimes your model should be able to identify good student as like a bad student. Are you okay with that? Or you want to understand whether you don't want to compromise that, because if you do that, they will get hurt and they will get demotivated. Or maybe you want the bad students to be identified as the good student, right? So maybe this is not very not this is okay in the United States scenario, right? So you want to compromise on that, but not on that. So you have to specify whether you want to compromise on the false positive rate or the true negative rate, or false negative, false positive. So type 1 and type 2. And based on your metric, then you can basically build your models. But if you're using the AI model built by some other company or any other some other people, I'm sure that they're all really aware of these techniques. And if they're not, then you can always chat with them so they can tweak their models. And tweaking the model is not it's not a problem. There's something called when you build this model, there are some parameters. Finding the parameters, you can change one or the other icon.
But this is a very helpful graph, I find. But there was one comment there in the chat about the diffusible.
I'm also AI regulation. Yes, they recently EU had the AI regulation. I'm not very much aware of like what they have done, but they have recently did like last month they produced some regulations around AI tools. So one of the things, for example, I know is AI cannot be used to score in the like scoring system, like score like social scoring, for example, because that can harm a lot of people. So they have been those days. So they have categorized some usefulness as okay, not okay, and in between. So that are
I'm sorry, I think in terms of the uncertainties, in some cases, I think you can also use an algorithm better quantify the uncertainty of the model performance. We kind of go in processes. For example, I know in language assessment, there is a company that use the golden processes to quantify the uncertainty of certain outcomes. For example, those borderline cases. So they will automatically the decision to regulate those. Manager let them judge whether they are true problematic or you should ask their family. So it's also bringing humans back to the loop.
Yeah, idea. Exactly. And also, if you to go back to I remember like one of the founders of AI in UNG. I told when I told this lecture a long time ago, he mentioned that I mentioned the base rate, right? So base classified base rate. These are the most optimal solution, but not always achievable, right? So the way you achieve the base rate is by adding humans in the loop, like asking the humans to rate the AI model and then providing the feedback. Yeah, there's one more question, and that's what I'm like. So for regression models, is true representation what we should aim for when often there are systematic biases affecting this. So for the systematic biases, this is I'm sure that people who are working on the algorithms. So systematic biases, and I guess it mean by algorithmic biases. So algorithmic biases, I'm sure they are taking care of algorithmic biases. The people who are working on these models and the biases in the model. But the representation biases that team work more hard to tackle it. And the reason is because they're using historical data set, and the biases are already present in that historical data.
Yeah. Okay, thank you so much. I think we need to draw a line here. That before we go, and you might meet with Muntazi after we wrap up, but we continue next week. Our speaker for next week is Jasmine Whitebees, and we're sitting here. We will talk about the potential of mobile interventions in education. Visiting researcher this term from the DIP in Germany. So I'll welcome them again. If you still want to give one last comment, that will be rushed, but then we need to draw a line, absolutely. So you're on next, I can find out comment. Thank you, first of all. That was extremely interesting. I wasn't aware, or it's much other. At some point, you mentioned that data might be labeled beforehand, and I can imagine that one of them can be set by humans in terms of how represented is that one. But isn't that just moving the problem from one state to the other state? Is the people who label what people who assess the model from aren't they biased themselves? Yes, if those are the people who created the data in the first place. I wonder how that cycle can be broken, or do you see what I mean?
Yeah. I think I had a slide, or maybe I just removed the slide. But I did have some comments regarding that. Let me see. I have something where I missed.
Or you might be mentioned something like states.
Yeah, so I think here I feel like people are involved in full life cycle of the project. They collect the data, deliver data, they have a whole set of rates and affect and introduce biases.
Yeah.
And so this is actually very important because in any AI system, you need to label the data correctly. And so if someone is labeling the data and introduces their own bias in the data, that's a really big problem.
Especially perhaps it's such labeling speed, maybe even the US, so then the labeling might be biased.
Sometimes, most of the time, the labeling is outsourced, and they collect the data, they outsource the data to some of the countries to label that. And so I don't know how they're labeling, and if there are some restriction or regulations around how they should label. But these are very important because most of the bias will come from labeling data. And that's why AI images that I showed are extremely biased, because when you scrap the images from the website, they not only scrap the image, they also take the text associated with the image. The text is like a label to that image, and they call it alt text. Alt text is like how AI will explain that image to a blind person. And the alt text can be very offensive or sometimes, and therefore most of the companies are building these sophisticated models. They don't show their data set because most of the time the data set contains offensive alt text associated with the image.
A very complex word. Thank you, Marek.
Thank you. Yeah.
That's really interesting. And I think that I think that I like to keep a copy of those specialized to pick up and the practice that I like the multiplication of this type 2, type 1 there. And I haven't seen that before that here. But all the things it did that, at least it's really clear. And the actual, there must be a point where it did. That's what labeling is. So the coding of the or between that Friday and that Monday morning, that's that like that was that bar that's it's some Friday and you're on it or say that would be said that very important. I'm seeing our the side reading the call. I think should we have well that it's then I around is that for and start with is having the AI that cannot recently the question and sharing me knowing about these very interesting and I think it incredibly funny is you talk about the very easy about these states coming out and I think that you say the range of error is towards the sun here right after I will face check that actually put these scripts in and have the ways and then that the turn out be of yes that I can see that it's
Look at values out of it, and I they haven't been data about that slow together. I'll be interactions and what should it's important in that we just continue to be feeding obese to it. And in fact, we're feeding our eyes influence that are not the more and then we can sort of equal actions. I have a big idea, it's not really when it's out of the child, and that's to put it. I really fascinating. That's really some of that there's same. Yeah, I think you're all in bed. The latest ones for the talk is now looking out the outward see on the much content that he very they see it says yeah, it's trying to unpack the essentials, which is something that I see that was a sad thing that I have something run is like research. Yeah, so I think you mentioned that the quantization is one between the buyers and it could be that works more on night one. So post validation and each of the I want to send you